Hello there. I'd just like to welcome you to our next session, and I'll introduce our next speaker. Jake Young is a senior software engineer at Hamilton Robson with background in native mobile development, full stack engineering, and interactive technology. Jake has experience in React and React Native, AWS, machine learning, and game development. With that, I'll pass you over to Jake to introduce his talk. Thank you.
Thank you. Welcome, everybody. Many of you likely have pets or have had them in the past. I think a lot of us see our pets as companions. I know that I see that in my dogs. And here are my companions for reference. But what does that have to do with a modern digital pet? I'm building a modern digital pet called Friend. Friend offers you the opportunity to nurture a digital life form who grows with you. Time you spend with it and actions you take are formative, informing how your friend learns and evolves over time. Over time, your friend can learn new skills and ways of communicating. But who am I to be up here sharing with you that I'm building something cool? I'm Jake, a senior software engineer at Hamilton Robson, where I've been for the last 5 years. Before that, R&D at Kainos and at uni game development. Through my career, I've had many opportunities, both in enterprise and creative projects, to learn how to apply game technology, AI, and scalable architecture. So I'm at a strange crossroads where I feel a lot of the technologies that I enjoy and build day to day are colliding in this weird hot pot. From that, Friend emerged as an opportunity to combine everything I know to build something magical. But why am I building it? LLMs and agents have opened up something really exciting. We now have technology that can adapt to effectively anything we give it and remain fully autonomous. But I don't believe how we're interacting with these tools is effective. In fact, I think it's inefficient. How many of you get frustrated when you're in a thread asking questions and the quality starts to drop when you go one message too far? Or when you're mid-thread and you want to fork off and ask something else to then come back to your original conversation? These tools still can't keep up with how we think. They're close, but they're still not there. Technology, when it works well, disappears. So I've been asking myself what that means for agents. Combine that with all the potential they could introduce for games, I've been building my excitement around that future. Looking back through my life, I can point to a number of things that inspired me, especially for Friend. So let's start there. This is my inspiration for Friend. I call it the nostalgia graph. Why? Well, a lot of us in this room grew up with all of these games, for better or for worse. So let's start in the bottom left. What do you get when you combine an LCD screen, 3 buttons, and a keychain with some amazing engineering? A Tamagotchi, or an egg friend if you try to translate it. It came out in 1996, and it would be a pet that wouldn't bark, meow, or make a mess. Perfect for parents looking to avoid getting their child a dog or a cat. And fun fact, when I was looking into this, there is a cemetery in England for Tamagotchis. Rest in peace, Gotcha Tatcha and Marcus. Released in 2005 was Nintendogs. Your dogs would stay puppies forever, keeping it fun and playful. Your dogs could play with other dogs, and over time, your dog grew hungrier or dirtier if you didn't care for it. You could train your dog to compete in competitions or do tricks on your voice command. And you could even dress them up. In 2010, and actually just released for its 15th anniversary, is Tom the Talking Cat. You could poke, feed, or talk to Tom, and he would mock you if you did talk to him. And interestingly, it's one of the most downloaded games with 1.5 billion downloads, or most downloaded mobile games with 1.5 billion downloads. And over those downloads, he was poked over 260 billion times. Animal Crossing, more recently, and with perfect timing for COVID. I know I spent many hours building my island and caring for its inhabitants, but some things they all have in common. They're all fun, and they also captured the rewarding act of caring for creatures. One thing is super important, though, that they all share, which I think was key to their success: portability. Keep that in mind as I'm going through the rest of the presentation. But before I go on, though, there is one more honorable mention that I want to put in here, Spore. Spore was leagues ahead of its time. From a single-cell organism, you could evolve your species into a space-faring civilization, no matter what it looked like. But the beauty of this evolution system was that it was your species. You had complete control over how it evolved. So let's go over some goals for Friend. I want it to be offline and secure, first and foremost. Voice first with visual feedback. Personalized growth. And I guess even more importantly, fun and dynamic. It is a game after all. So to achieve those goals, I'll be using this architecture. Expo is the foundation that the app is built on. I can build across iOS, Android, and the web all from one codebase. It's built on React Native, which compiles the native code, meaning it's performant and extendable. It has great developer tooling and a great ecosystem with modern libraries. I'm using React Native Executors for local model execution on mobile devices, built to be run across multiple platforms, so it's optimized and it allows you to bring your own model. And finally, I'm using Three.js to deliver the visuals. A mature, open source 3D library, which is very capable, and combined with the React, is very scalable too. Everything from Apple's website to SpaceX's Dragon capsule that has delivered humans to space, use it. So with every software project, it's good practice to break it down into spikes. Isolate your feature, test, and qualify that you can achieve what you want. Our friend needs a brain, and it also needs a way to listen and communicate with us. So I started prototyping a conversational agent. My goal was to have an LLM model, a speech-to-text model, and a text-to-speech model, all running locally with a response latency of less than 1.5 seconds. For the LLM, I used models like Llama with 1 billion parameters, but they were too slow. Anything bigger would be the same. So I looked for something smaller and found a Qwen 3 model with about 6 million parameters. For speech-to-text, I have two options. I take advantage of native OS tooling that have been around for years and are super efficient, or I try and use a small variation of the Whisper model, which is a lot more accurate but slower. And for text-to-speech, again, I have two options. I go OS tooling, it's a lot more mature, but I don't think the quality is good enough anymore. Or the better alternative is to find a text-to-speech model that'll be slower, but will output a realistic voice. So I'm going to attempt a demo. It's been a bit flaky with me this morning, so bear with, and hopefully it runs, but let me just swap over. So what I wanted to show you, let me just reset this. Give me a sec. Okay, is that working? Yeah, okay. So all I'm doing is capturing the app that I have on my screen. Now it's very prototypey. It doesn't look like a companion that you would want to have fun with or interact with. This is representative of the spikes that I'm trying to build to prove out that it's possible. And remember that my response time that I wanted to achieve was less than 1.5 seconds. So I'm going to try and talk to this. Again, it's been pretty flaky, so we'll see if it works. Hey, how are you? The door didn't open, but in any case, it responded to me, and Whisper processed what I was trying to say. And you can see in the top right, hopefully, that the first token, that's the most important measurement here, came back within 1 second. Now, it was quite a long response, which added to the time, but more often than not, you'll get less than 1 second. There was no voice, but that was just a breaking thing that I've done this morning, so forgive me for that. But at least it proves the point, and I know it works. So let me just hop back to my presentation. Perfect. So now we've seen it work. I now have an agent running completely local on my device. There's no API calls. It's completely secure. But the whole point of this app is to experience growing your unique personal friend. So I need to enable the agent to learn. I started thinking about fine-tuning with the data set captured from the app. But without the original data set and the thousands of GPUs the model was trained on, I immediately lose the intelligence embedded in the model. So that's a no-go. The next place I went was LoRa, which allows me to keep the base model I choose, but train an adapter of a small data set or subset of parameters that I can control and attach to it, making a 6 million parameter model into a 6.1 million parameter model. But that would require setting up back-end services to offload the training from the device to something with more compute power. That's something I'll pursue in the future, but it's not for the current prototype. Finally, though, I arrived at memory. When researching how memory was built into LLM tools, I discovered this term, lifelong memory. I was surprised to find multiple papers focused on this concept, even before agents were a thing. This paper in particular was really interesting to me, given the way they handled learning and growth for each of their characters that they created. They built a small town, that you can see here, with multiple agents that interacted with each other. With every interaction, they used their memory and understanding of self to drive their decision-making. As an example, one character had a birthday coming up, and the others were able to plan for it together. So it made a lot of sense for Friend, but it needed translated to my needs. So first, we need to be able to store and retrieve memories. To do that, we need to use embeddings. Often when we talk about applications that use embeddings or vectors, they're delivered through the cloud, which often makes the most sense. But in this case, we need to be local. So with a vector extension for SQLite, we can achieve this pretty easily and with solid performance. For those not familiar with embeddings, take a look on the right. Every white point that you see plotted in 3D space is a memory. The embedding of that memory is simply an array of numbers that represent its meaning relative to other memories. Because they're stored as numbers, we can run a really fast semantic search across them that will return the most relevant memories to what we asked for. And to achieve lifelong memory, relevance is super important. So I want to introduce you to the evolution agent. This agent will drive evolution, decision-making, and learning. It will control the growth of your friend based on how you care for it. Under the hood, it's the conversational agent that you just saw, but in combination with lifelong learning and multiple game systems, your friend can use it to make informed choices about how it interacts with you and its environment. To achieve all this, we need to implement a few more things, though. So now that we have memory, we need memories to create. To do that, friend needs to perceive you, itself, and its world. Let's start with you and I. We will be the main driver of any interaction in Friend when you open the app, when you talk to your friend, or when you feed or play with it. All are perceived and stored as memories. Interactions from you will drive responses from your friend. Game systems such as hunger, energy, and loneliness will also be noticed and stored as memories. And the environment can also be perceived, like if your friend discovers a new place to hide when you play hide and seek with it. All of this gets stored as memories that will later be used to influence action or inaction. So memory is great, but how do you and I grow as people? How do we learn and eventually find out how we should act? We reflect. Every day, you and I collect a load of memories. At the end of the day, we tend to reflect on what happened and learn what we can from it. Like today, I'll remember I gave a presentation at NIDC, but later I'm going to think back on how it went and discover insights that I didn't have before and how I can improve myself with that, like not building a demo 5 minutes before the presentation. Our friend needs to do the same. This should be a scheduled process, and it happens in 3 stages. First, starting from the left to right, our friend looks back at the top 100 recent memories from the time they were made. Often this would just include the memories from the day that it was you played with it. Taking those memories, it asks itself to come up with 3 important high-level questions that can be answered about the subjects in your memories. We then perform a semantic search, a relevant search, on the database with those questions to retrieve relevant memories. And finally, we have the most relevant memories. Once we have the most relevant memories, we then ask our friend to come up with 3 high-level insights or reflections it can make from those memories. But what do we do with those reflections? We store them as memories as well. So not only does our friend remember specific events, it remembers what it thinks about them. And you can see a very simple example down here. So when the user, from a bunch of interactions I've had with it, I've opened the app, I've went to play fetch with it, I've won, it's won, I've lost, it's lost. But it's recognized that when I open the app, I want to come and engage with it, I want to play with it, I want to entertain it. So it's created this reflection of when the user comes to visit me, I get excited and want to play. All of this gets fed back into the system to help our friend grow and evolve. So now we have the key systems in place: perception, memory, reflection. But how do these components connect to influence your friend? Let's go through an example. So I go to open my app, and my friend is in a resting state. He's tired. So it perceives that I have just opened the app, and I've spoke to it in an excited voice, similar to how I would talk to my dogs, to be honest. And from that, it goes and looks at its memory and sees that the user usually plays with me when they sound excited. So it needs to make a decision. Should I react? Yes. And the action I'm going to take is I'm going to stop resting, I'm going to show excitement, and I'm going to prepare for play with my friend. So I'm going to try a second demo or to show you what that's like. So bear with while I swap quickly over. So I have to drop that again, 2 seconds. So what you can see here is a way that I've tried to visualize that entire process. So I need a way, going back to how I talked about building spikes, I need a way to test all of these systems and make sure they work. So first, if you remember, is perception. It needs to perceive its environment. So, and the main way the environment gets changed or things happen is really through me and other game systems. So focusing on me for now, I'm going to go and feed my friend. I'm going to play a game and win. And maybe then my friend becomes hungry. So these are all events that it's perceived. Moving on to sort of the second stage of this is that, okay, I perceive my events, they're memories, I need to store them. And that's when they go into this list where you'll see recent observations. And at the top of the list, you'll see that I'm starting to feel hungry. My friend and I played a game of fetch, I won. And my friend has fed me an apple. All of these things are triggered by me, but they could also be these events could also happen in the environment, or it can even do them itself. And what's really cool is that if I go and search, I can then search, use the relevance, the semantic search across these memories and get the most important ones. So if I go and search for a very basic query of apple, I'll go and get mostly memories to do with being fed an apple, but also conversational insights that have been made, or event insights like reflections that have been made that are about being fed or being about an apple. The last stage of this is reflection. So this would usually run maybe on a scheduled basis, once a day, twice a day, but the idea is to basically try and condense all the memories that have happened, the discrete actions, into high-level insights, like I was saying. So this is quite a wordy one, but like I said before, a good reflection would be that it recognizes that when I open the app, it wants to play with, I want to play with it, and it should be excited. And it's getting that from the pattern of interactions that I've had with it. So let's go back to slides. So the context from memory, the stage gets passed in every time your friend is expected to respond. So it always understands what its intent should be, how it should respond. And what's great about this as well is that it's always aware of the most important context, no matter how many tokens deep you're into a conversation. So context windows aren't a problem. So really, we're solving two birds with one stone with memory: personalization and infinite context-aware interaction. But there's a final important piece of the puzzle. It's great our friend can make context-aware decisions and actions, but if we left it there, then our friend would only ever be taking informed action based on triggers and otherwise appear unmotivated. What about its motivation? What does it want? That's where planning comes in. Planning asks our friend to be aware of its current state, so its hunger, energy, loneliness, and also look at its memories to plan what it wants to do that day. So in the example above, thinking about how lonely it is, it wants to get the user to play with it, but how will it do that? When the user opens the app, our friend will use its plan to drive behavior. It will appear playful and prompt the user to play with it, maybe by bringing a frisbee to throw so it can play catch. And if you decide not to play with your friend, it will remember that, driving future planning and actions. So I guess to wrap up, I want to look forward into the future to what friend could be. Currently, our agent system is capable of tool calling, but what if we allowed it to discover more tools and skills through its exploration? What if we let friends visit each other to share what they've learned from their users and distribute knowledge and skills? And if we have skills, why can't we let our personal trained friend help us day to day? With access to the right, eventually mature SDKs, computer use would be possible. So thanks. Just before I wrap up, I want to give you a bit of a teaser. So let me swap over again. We're still good. So let's create our companion. I'm going to name him after my best companion, Archie, my dog. And here's a sneak preview of what's to come. Again, very early prototype, but with all of these systems combined, can create for a really powerful experience. And again, it's offline, secure. Thank you.
Thank you, Jake. Just wondering, are there any questions from the audience? If you raise your hand, we'll bring a mic to you. Question here.
Thanks. Really, really interesting project to do. I wish we could build invisible friends.